Okay, so we've learned how to simplify rational expressions, so single rational expressions, talk about their non-permissible values. Now we want to learn how to multiply and divide. So really, it's very similar to multiplying and dividing fractions. So that's what we're going to practice here. So it says simplify each of the following expressions, so it's multiplication. So remember, two ways to do this with numbers. You can multiply through the numerator and denominator and then divide out, or divide out common factors right away. And that's really more of what we're going to do with rational expressions. So here, 2 goes into itself once, into 8 4 times, and then we're left with 5 twelfths. Okay, so our greatest common factor was 2, and we divided that into the numerator and into a denominator, either within the same fraction or within separate fractions. Next one, these are pretty big numbers, so you might not know sort of right away. 42, I know 6 goes into that, so I'm going to divide that, get 7, and 6 goes into this 20 times. Okay, then I know that 5 goes into this 3 times, and 5 goes into this. 5 goes into that, 35 times. So still I can reduce, but maybe you want to show that multiplication right now. Totally up to you. What's that? 210 plus 35, 245. And then you can divide by 5 again. And that's going to be 12. 49, 12 over 49, okay? Next one, we're dividing fractions, so you invert the divisor and then multiply. So you could simplify within each fraction before flipping it. I just flip it first. That's what I'm going to do with rational expressions, and now I look at that, what can I do to simplify this? Well, for sure, 4 goes into this 9 times, into this 5 times. For sure, 5 goes into itself once, into 15 3 times. And 9 goes into 54 6 times. So, from that, actually, I get 3 6, which is 1/2. So I can divide the 3 and the 6 right away as well. So sometimes with numbers, you're going to maybe do it more than once just to keep track of what's happening. Notice how here, in each case, we're dividing by common factors. So here, in the second one, I had it divided by the greatest common factor, okay, because I had to do it twice. Here, I had divided by the greatest common factor because I had to do it twice. If you start out right away with the greatest common factor, then you shouldn't have to reduce at the end. But the biggest thing is that you're looking for factors. There's no adding or subtracting anywhere in here. Some rational expressions have adding and subtracting. You can't divide out a term, just factors. So let's take a look. With rational expressions, here's the sort of the steps. Fully factor everything. Determine non-permissible values from the factored form. Reduce fractions where possible by canceling. I like dividing out. It's a better word. Common factors. For division, flip the second fraction and change to multiplication. Look for non-permissible values again. Then multiply numerators and denominators. If possible, cancel common factors again. That's usually, if you've got it done in the first step, you're good at the end. When it says multiply numerators and denominators, you can keep in factored form. So you're just showing it in one fraction. Very rarely do we expand them back. Okay, so the first one, simplify each, state non-permissible values. These are all monomials, so it's kind of like dealing with the numbers, right? So 3 goes into itself once, into 18 6 times. 7 goes into 14 twice, into 21 3 times. I can divide out the 2 as well, if you can see that.
okay? So really, I'm going to have something over, so basically it's 1 over 9 right now. And let's see about our variables. Okay, so we've got a squared, a to the 4th, so that divides in squared, and then b squareds divide out. Okay, and so really I've got, now I can just make that a squared. Over on the right, I have a goes into a squared 1, so I have an a down there and a b left in the numerator, and now I can simplify that. So I'm left with ab over 9. Okay, we'll do that in red. So this divides out there. So I did it in 2 steps. You could have expanded this out. So 3 times 14 is 30, 42. I'm just going to need to erase this so I can see the exponents. So that's going to be a to the 5th b cubed over whatever 18 times 21 is. 378 over a to the 4th b squared. And then greatest common factor there is going to be 42, I think. So 378 divided by 42 is 9. Yeah. So that goes into itself once, into this 9 times. And then you can see that you have 9 left here. A to the 5th divided by a to the 4th is a. B cubed divided by b squared is b. Okay, so either way. All right, so now let's get into the ones where we actually have to factor, right? So you have to factor everything first. So the first, that's trinomial over a difference of squares. Common factor here, so 1 bracket, and then a trinomial. 2 numbers that multiply to 6 add to -5. Oops, that would be -3 and -2. Difference of squares, x plus 3, x minus 3. Common factor of 2, with x plus 3. 2 numbers that multiply to -4 add to -3. So you can use decomposition, and you can show your work on the side, or trial and error. That's going to be -4, so I need a -2 and a +1. Now I'm dividing out my common factors. So I see an x minus 3 and an x minus 3 within the same rational expression. So that's easy. I also see an x plus 3 in the denominator of the first and the numerator of the second. It always has to be between a denominator and a numerator, never across. And then I see an x minus 2 with an x minus 2, numerator, denominator. So really when you're dividing this, you're left with 1s, okay, that you're multiplying by 1. So here you have 1 times 1 times 2 times 1 is 2. 1 times 1 times 2x plus 1 times 1. So 2x plus 1. In terms of your non-permissible values, you go back to your factored form of both fractions, both rational expressions. So from the first one, we have -3 and +3. From the second one, we have -1/2 and +2. Okay? And we're done. Next one, notice how it's a division. So really to save yourself 1 step, you can factor as you go. Okay? So numerator is 2x plus 1. Denominator, there's nothing to factor in that numerator. Okay, denominator, 2 numbers that multiply to 15 add to 8 are 5 and 3. Now we're going to invert and multiply. So change it to multiplication. So the x plus 3 goes in the numerator, nothing to factor. The denominator 3 is common, so I factor out the 3. Okay. Now, when I look at this, all I see that's common is x plus 3 and x plus 3. I also see an x plus 5. It's common, but they are both in the denominator now, so we cannot divide those out.
Okay, so what are we left with then? We're left with 2x plus 1 in the numerator. Always like to put the monomial out front, so 3. And we've got two factors of x plus 5. So you could show that as 2x plus 1 over 3 times x plus 5 squared. In terms of your non-permissible values, you look at both denominators, so the denominator of the first rational expression, so negative 5 and negative 3. Denominator of your second is negative 5, we've already included it. And as well, you should look at your original denominator of x plus 3. Well, it's actually already included, so no extra restrictions, but you do always have to check. So for dividing, you have to NPVs, you have to look at both denominators and second numerator, okay, which is actually the divisor's numerator, okay. And the third one, again, it's a dividing, lots of factoring. So when I look at this, I see that there's a common factor and then a trinomial, right, to factor. So I'm going to do that work on the side. So equals 4 times x squared minus 3x plus 2. And that is going to be x minus 2 times x minus 1. So now that I've finished that factoring, I put it back into my equation, or my expression, because I don't want to show factoring steps, step after step. Next one, I notice a common factor of x squared. That's going to be x minus 1. Nothing else to do with that. Now, it's a division, so I'm going to make it a multiplication, and this now goes in the numerator. So that is a non-simple trinomial. It's going to be 3x and x. Two numbers that multiplied in negative 6 add to 5 would be positive 6 and negative 1. So plus 2 there, minus 1 there. Now in my numerator that now becomes the denominator, I see there's a common factor. And that's a difference of squares. So again, I'm going to do this on the side and then put it back in. Okay, so now what's common? So within the first fraction, x minus 1s. Within the second, x plus 2s. Anything common between them? Yeah, x minus 2 here and x minus 2 here. Okay, a numerator and a denominator. This bracket is not common, the 3x minus 1. 4 doesn't go into 5, x squared, nothing to divide, so just write out 4 bracket 3x minus 1 over 5x squared. Restrictions. Okay, look back to your first denominator. So if we got x squared as a monomial, that's 0, and then 1 for the second bracket. Then for the second denominator here, we've got plus or minus 2, so you can abbreviate it with a plus or minus. And remember, you have to go back and look at the numerator here, because really it comes from numerator and denominator. Denominator of the original becomes the numerator after you flipped it. So you also have to include 1/3. So don't forget. Okay. And that's it for that lesson.